Evolution example question 1. There's a population of owls in Florida. They were the result of 3 pet owls being illegally released. What was the initial event an example of? Okay, population bottleneck. I mean, although it is a really small population, it's not bottleneck really. A bottleneck has more of a catastrophic event usually associated with it. Could be gene flow. Okay, gene flow is more associated with migration. This isn't really migration because it isn't joining a new population. It's just kind of like popping up. And founders effect. Okay, this would be a founders effect. So there originally was a population of owls, and then they were taken, and then they were taken to Florida, and then they were released. So they're kind of like founding the new area in Florida. Just these 3 owls. And a genetic drift is like the random change in allele frequencies, and yeah, no, it's too general. It doesn't really apply here. Okay, example question 2. The same owls we were just talking about are native to Argentina. We bring like 100 of them to the Florida population for some reason. And what is this an example of, and what effect would it most likely have on the number of alleles? So we know that this will be gene flow. We're talking about like a migration. So the organisms that are in Argentina are now bring their genes which flow in to the Florida population, and because they're bringing additional genes, they're also bringing additional alleles, which means that your number of alleles will go up, which is a good thing for the Florida population, at least. Okay. Evolution example question 3. Your friend has like 3 million ants. She gives you 43. What is this an example of? This would be a founder's effect. So these 43 would be founding a new population added to 3 million. And let's say that the allele frequencies are somehow about the same at the time that you're given the 43. So this is like basically impossible for that number, but let's say that the allele frequencies for 43 are the same over here. True or false? Over time, it is likely that the allele frequencies become different due to genetic drift. This is true. So our population of 43 is very small and is very susceptible to genetic drift. So the allele frequencies can randomly change. Something can randomly not breed, or it can just like die, or it can breed too much. But for whatever reason, the allele frequencies will change, and they will be different than the 3 million ants, almost certainly. Evolution example question 4. There are beavers. There are 4 of them. 2 of them have hazel eyes, and the other 2 have brown eyes. Eye color does not have any fitness difference. What is a reasonable statement? A. Because hazel and brown don't do anything for fitness and are equally frequent, both allele frequencies will remain the same. Or B. Either hazel or brown color allele will likely be fixated or eliminated in the population. So, okay, A, that kind of makes sense, because like the allele doesn't have any fitness of benefit, so neither one would be favored, and because there are 2 and 2, they're also equal. So it makes sense that they would both just remain around 0.5 for the frequency. However, this is not the case. This is a very small population, and small populations are very prone to genetic drift, which we talked about this specific instance earlier. Even though you have a neutral allele in a small population, it can be fixated or eliminated by chance. Instead of eliminated, a phrase is used called goes extinct. So this would be the thing. So either hazel or brown can be fixated by genetic drift, and then by the act of being fixated, the other one would go extinct. It could go either way. They're both like the same. Okay. Evolution example question 5. Apes with big eyeballs mate a lot more. What might the current population look like in 45 years? This is our current population. We see that it looks to be like this population was probably under stabilizing selection for a long time. And that makes sense because, eyes, there's not any particularly benefit in them being like too big nor being too small. So just around the middle, that's fine. But because of anime, apes with large eyeballs are now much more attractive. So that would be like having big eyeballs is a fitness benefit because they get to mate more. So no, that would not be A, because we see that that's basically the same as what we have now. But it seems like it would even be even more favored to be in the middle. Doesn't make sense. B goes this way, and C also seems to go this way. Okay. Well, you can make the argument for B or C, but what I kind of meant, what I meant a lot more is that like a lot more, like it is a huge fitness benefit. So eventually, it's such a big benefit that there wouldn't even be any middle ones. But again, B would also be. You could also argue for that. Honestly, it's kind of a stupid question. Also, professors are pretty reasonable. Like if you have a question on an exam and afterwards when you're looking over, you're like, hey, I really could have argued it this way, right? If you ask your professor politely and you explain it to them, many of them are pretty reasonable. All right, so that's the entire thing. Thank you for listening. I know it was very long. Sorry about that. I have office hours. We're gonna in my office hours this week. We can go over practice exam problems in detail and stuff. And email me if there's ever anything I might be able to help with. And really, good luck on your exam. I'm gonna go brush my teeth now.